Hello all, welcome to Tech with Sass. In this video, we will discuss yet another design question which is very popular in interview questions. That is how we design our URL shortener system. So interview will ask you that design a system that takes a very long URL. For example, here, right, we have a long URL, this one, and create a small URL, right, a short URL. So how it works basically, so concept here is that sometime we need to have some short URLs when we want to basically give to customers or in some places where is lack of space or lack of memory, right? So we want to use the short URL for like more readability point of view. So here, right, you can see that user will have like two type of request. First request is that when they want to register in your system, which create the short URLs, for that, they will be sending a long URL, right? Like we can see here, right? Then yellow, it says it is sending a long URL to the our API, and it is now getting back a short URL, right? But now it has got this URL, right? So in our system, what we will do, we will have a mapping, right? So we have a maybe a table or some way, right? Table or file, whatever. We have to map this, right? So the original URL, which was received by the user, and the small short URL which we have created, right? So now request for this creation is fulfilled. But what happens in case now the users or the client type this URL, right? So you can see here when they type this URL, so they will request for the direction into your system. So now once they type this small URL, and hit on the browser address bar, then you get a request for redirection. So our system knows, okay, this short URL is mapped to this big URL, right? So what we do, we take this small URL and basically the redirect to the bigger, the main URL, right? So this is the whole design at a very high level. That at nutshell, we have two requirement. One is the user requesting with long URL to create a short URL, and second request is that whenever they are trying to access the short URL, we are redirecting them to a big URL, right? So that is the main requirement here. So now, when you have this clarity, right? So now you have to ask into about the requirement, like what requirement they need, right? Always remember that requirements come into two flavors. First is the requirements which are functional, where we focus on the functionality of a system which we are designing. And second requirement category is where we focus on aspects which are non-functional, right? So always do a cross questioning with the interviewer, clarifying that which aspect in non-functional requirements are more important, or what you think, right, which are like more important, and discuss first before you go ahead in the designing. So let's see requirements one by one. So first is obviously we have to create a system where it can create the short URLs for the long URLs passed. Second is the redirection. So whenever user type the short URL in the browser of any system, you are basically doing redirection to the main URL or long URL, right? Third is the custom short links. So sometime companies need to retain their branding, right? So maybe a domain name or brands, right? So in case they need some custom short links, we have to be able to provide that functionality as well. Next is deletion. So by default, we can assume that maybe we will store the this URL mapping for 5 years. But in case any user want to maybe retain for longer or shorter time, we can also customize that part. So we can delete the short links maybe after some time as per requirements. Then also the update. So suppose sometime they require to update the URLs, that also can be done by this system or application. At pi time, so maybe by default, if we say that okay, each mapping of short URL will be stay in system for 5 years. So, but user want to, I mean, keep it for maybe 10 years or 20 years, so they can be able to do that part as well, right? So now let's see the requirement which are non-functional. First is availability. Availability is really important because you are handling with websites or the links, right? So even if your system is down for like maybe a few milliseconds, that's going to cause a havoc in the whole users because they can't able to access their website. So we have to make sure their system is highly available. Scalability, definitely. So when popularity of your application or system grows, should be able to cater the more requests. Maybe if there are like some occasional spikes, maybe because of some festival shopping or whatever, right? So you have to make sure that you're able to scale system horizontally, right? So that you can add more machines and cater to more traffic coming to your application. Readability, definitely the URL should be very small and should be readable by the users. Latency, so we have to make sure that we are serving our customers as quick as possible. And there should be some SLAs, maybe they will be in maybe milliseconds, so we have to honor them for sure. Then we have to make sure that whatever URLs we are generating, we should not be able to, I mean, should be basically unpredictable. So nobody can guess, okay, what is the next URL we are going to create. So we have to add some kind of randomness in our URL creation. So these are some requirements which we have to first jot down and also discuss with interviewer and then proceed further. Now, once we have requirements frozen, right? So design a system, right? So we need the storage requirement, we need the basic memory in cache, whatever. So right, so we have to make some assumptions because we have to start from somewhere. Maybe assumptions are not accurate and they might change, but we have to start with some data, right? So that we can basically estimate some capacity requirement in the system. So let's assume that the ratio of read and write will be 100 to 1. What it means that for every one request to create a new short URL, they will request 100 times more for the direction, right? So this is like a ratio for both. Then we can assume that maybe we'll get 200 million new URL sorted requests per month. So that figure, it depends like at what scale you are going to create a system and exposure. But in our calculation, I'm going to assume these numbers. Then, for every shortening entry, you are right, which we are creating. So that will require the space, some space, right? So we have assumed that it will require the 500 bytes in database. So you need also to provision for that. Then we assume that every entry we are going to make in our system that going to expire after 5 years. So we will have a some kind of mechanism that will clear out those entries which are like 5 years older by default. And then there will be 100 million users daily for this service. So these are like some assumptions we have taken. So basis on these, we are going to do some back of the envelope calculations that are required for the infrastructure of your system, right? Then let's do some calculations based on those assumptions. So first thing is that we have assumed that there will be 200 million requests will be coming for shortening, right, per month. So how many requests we are going to get in 5 years, right? So what we have done, we have multiplied by 200 by the 12 months per year, and then 5 years, because we are going to save each request for 5 years. So in 5 years, we are going to serve 12 billion requests for shortening, right? Now, okay, so, and we, if you remember that, we assume that every entry for shortening of URL, that is going to take the 500 bytes, right? So to multiply this number by 500 bytes, you get 6 terabytes. So we have to make sure that maybe our database should have capacity of 6 terabyte minimum, because we are going to have this much data in next 5 years, right? So this how you calculate the data requirement for your system. Then how many, query rate, right? So how many requests you are going to get per month for the direction. So we assume that we are going to get 200 million requests for the URL creation. But we assume also that there will be 100 times more requests for the direction. So we will get 20 billion requests for the direction. So so there will be requests, this will request coming for the direction of the URLs. Like they will type the short URL, and you have to basically give them the long URL and the direct to that. Now, if you want to get the how many requests for you'll get per second, right? So we have to basically divide this by the number of seconds in a month, right? So what we are going to do, so this is how we calculate the number of seconds in a month. So I mean, it's like a normal calculation. So this many seconds we have got for the in a month. Then, how many requests we are going to get per second for the sorting request? They are 200 upon this many seconds. So, in nutshell, for the new request, new sorting request, we will get like a 76 URL per second, right? So, uh, in 1 second, we are going to get 36 URLs creation in our system. So similarly, if you want to create understand like how many what is the per second you are getting for the direction, they are 7.6K URL per second for the direction, because we assume that the direction is 100 times more than the short URL creation. So this is like a some calculations which we do, they might be based on assumptions, and you can fine tune as you develop on operating system, right? So here we have got like how many requests we are going to get in 5 years, the storage requirement for the database for each sort URL, right? And then the per second, right? Per second queries, number of URL required for the shortening request, and per second for the direction we have calculated, right? Let's move further. So now we have to see like what is the bandwidth we have to make sure we have available in our system. So bandwidth estimation for incoming data. So we know, okay, for shortening request, we have 76 URL per second, and every request is of around 500 bytes. So if you convert to in the bits, so that you get like 304 kbps. So this much is the bandwidth required for the request which are coming for the shortening, for the short URL creation, right? Next is the bandwidth for the direction request. So because we know that the directions is like 7.6 KUL per second. So similarly, you get the 30.4, sorry, I mean, mistake. So 30.4 Mbps, right? So yeah. And also because there might be some URLs that are like more popular, and you are getting like request to write them multiple times. So it's really wise to use caching, right? So and once you use caching, because caching is a very costly memory, so you can't cache whole system. So you have to suppose you decide, okay, I will cache 70% of my requests which are like coming. So for that, how much memory you require? So suppose you have like for redirection, we have a 7.6K URLs per second. convert it to this much by per day. So that gives you 0.66 billion request for redirection, right? So if you want to flush memory in one day, so and you also want to just cache data which is like 20% of whole request, so you will need like this much memory for caching, right? So because like we can't cache whole data, right, of which is coming from the users, so we have to cache which is like most hot used by system. So this much is required for the caching storage, right? So now I think we have got the estimation of our infrastructure like storage, caching storage, and bandwidth requirement, right? How many devices we are serving. So let's see the design diagram. Here, I mean, system diagram is really simple. It's nothing fancy over here. So, I mean, because like we know that our system is handling the request in the billions of URLs, right? So, what we require load balancer because it's definitely we are not going to use one server. We'll have like maybe hundreds of servers, right? So how each server is going to get the proper load that is able to sustain in long term, right? So we have to use a load balancer. So whenever a user is requesting either for redirection or for the creation of short URL, the first component which he or she is hitting is load balancer, right? And because system is highly available, you have to make sure that, right? So we cannot let it go down. So for that, second important thing is that after load balancer, we have to use rate limiter also because rate limiter is something which is going to throw away the requests which are beyond the capacity of your system to be able to serve, right? So for example, you have a contract with some customer that, okay, I'm going to serve you the 10 requests per second. But customer is sending like more 20 requests per second. So for that, we require rate limiter, right? Because our calculations are based on that contract, that assumption. So we have to protect our system. So we have to use rate limiter. So the requests which are coming beyond the SLA, we have to stop them. So first thing is load balancer we are using here so that because we have multiple servers, so we have to distribute traffic accordingly. And then for every customer, we have a rate limiter defined so that it doesn't overflow the system. Because if we are trying to overstretch our servers, they are bound to go down, right? Next thing is that because what we are doing that for creation of a short URL, we are going to store in database, right? So we have database as well. So then for caching, we can use Redis cache. So the traffic or the data which is like more hot from customer point of view, we can store them into the cache, Redis cache, or whatever cache you want to utilize. Then we have our API service. So this API service will have some functions that we'll see in next slide, but it's like a very basic system diagram where you can see the components we are required like a load balancer, rate limiter, cache, database, right? And also our app service and API service. So this is like a very high level design system or diagram of your application. So now let's see the required APIs, right? So now you have understood the requirements like and also design the system. Also got the requirement like how much storage or whatever you need, right? Those things have done, right? Now it's time to design the APIs, like how many APIs you need and what are the contract and definitions. So I mean here we need like first API is the shortening URL definitely, right? So maybe you have some API exposed as a REST API, whatever. So you have like a short URL. Then you have app dev key. So app dev key will be something for a customer. So whenever you onboard a customer into a system, you have to provide him some like a key so that you know, okay, this is the customer which is going to hit my system. So then for shortening a URL, you have to pass the original URL, and for that you will give them the URL for the shortening. I mean the short URL, right? We'll give them that. And expiry date, they can pass none. So if they pass none, then you are going to default expiry as a 5 years. But if they pass some data, you have to honor that expiry date. Next is the redirection, right? So for every request or redirection, they will pass the API dev key. They're basically their key to identify the customers or clients, and then the URL key, right? The short URL, right? Which they have to basically redirect the long URL. Then deleting a URL, they can also provide, they can also utilize this API to delete the URL. So these are like a few system APIs. There can be few more, like creating a custom short URL, building URL. So I mean, you can define them as per your requirement, just for convenience. But this is like how you answer a interview design question, so that you are covering all the aspects and you're able to answer each question from the interviewer. And main thing is that whatever component you take into your application design also provide justification, like why you have taken the cash, why you taken the rate limit. So why is the rationale behind that? So you not take the default way. Okay, I have to take this like this, but no, you have to think first, like which component required for your system, then plug in into your application, right? So with this, I have covered a design question. Please go through this whole video, and I hope that you like this. And then please put any comments or question in the comment box. And if you want to basically focus on some other design questions, maybe you can put in the comment as well. I will definitely create videos for them as well. So thank you very much for watching. See you next time. Please leave questions or comments if any, and please subscribe as well. Please forward my videos to your techie community so that they can also get benefited, and also I get some support from you guys as well. Thank you very much.